Roger and Jordan, thank you. And I want to thank everyone for attending their talk today, which my talk is going to be on the use of passive soil gas sampling to collect high resolution, time integrated data to support site characterization and vapor intrusion investigations. As Mort's talk showed, spatial variability and subsurface contamination is the norm. And too many sites are being inadequately characterized by following poke and hope sampling strategies or allowing site access and manager bias to dictate where samples are collected. A sampling plan that collects high resolution data will better define contamination and create a better conceptual site model. But what is high resolution? I know we have a few people here from international locations, but for those of you who watch American sports, you've probably seen this commercial where the announcer asks, what is better, more or less? And the premise goes that even a child knows that more is better. And what we have found from conducting site investigations for over 20 years is that this applies to characterizing sites because of the spatial variability and subsurface conditions. So what sample spacing is reasonable to collect high resolution data? This slide shows the results of a passive soil gas survey with a grid that has 90 feet between sample locations. And as you can see, there are definite areas of higher measurements, suggesting the presence of source areas in a few locations. However, what if a tighter grid spacing was used, such as what was actually done, with 30 feet between sample locations? Here you see there are areas of contamination that were completely missed with a 90-foot grid, and even those areas where contamination was identified are much better defined with a 30-foot grid to reflect where the true hotspots are located. So more is better, as long as quality data is collected, which I'll discuss shortly. I'd like to get you thinking about how a passive soil gas survey can answer the question, where, for your projects. Where is contamination? Where should I collect soil and groundwater samples? Where is vapor intrusion risk? Where is the center of massive contamination at my site so I can focus my remediation and reduce the overall project cost? A passive soil gas technology is routinely used to answer these questions and guide project decisions. As Mort discussed and the prior slide showed, spatial variability is the norm at sites, and sampling for compounds and soil gas allows you to overcome that challenge by collecting more data because of the lower costs associated with collecting the samples as well as analyses. Plus, a time-integrated passive sampler is absorbing compounds over days or weeks, and if there is contamination in soil or groundwater in close proximity, the soil gas will be contaminated, which will be absorbed by the passive sampler. With soil or groundwater sampling, you need to sample at the exact location and depth to identify whether contamination is present. Therefore, the broader area of influence of a passive soil gas sampler allows for a PSG survey to be less likely to miss contamination by reducing data gaps between locations. A passive soil gas survey also overcomes the challenges from the temporal variability in soil gas concentrations by collecting time-integrated samples over several days or weeks. Now, Mort showed where there was really high concentrations, there wasn't much variability, but what we've seen is that there is temporal variability with lower soil gas concentrations. And that's been supported also by what Dr. Paul Johnson saw out at the Sun Devil Manor House out in Utah. As the table notes, not only were 2 orders of magnitude variability identified spatially, but an order of magnitude variability was seen temporally. And this is in agreement with what we've seen also at sites, and in fact, it is common to have significant diurnal swings in soil gas concentrations, particularly when no concrete or asphalt covering is present. Now, Beacon's technology is provided through use of soil gas sample collection kits, which we ship out to our clients for them to collect the samples themselves. They're shipped out in a rugged toolbox. It's approximately 20 inches by 10 inches by 10 inches. And it's shipped out with a tug-tight custody seal on to make sure that nothing's tampered with during delivery. Each kit is custom packaged with the appropriate number of samplers, depending on the size of the investigation, whether it be 10, 20, 50, or 100. And no ice or preservatives are required for shipment, which makes it a lot easier to ship these not only throughout the United States, but internationally, and you don't have to worry about short duration for shipment times because the hold time on using adsorbent samplers is 30 days. And the kits include detailed instructions, and there's also installation videos that can be found on our website. This is what our sampler looks like. There's various ones out there, but ours is about the size of your pinky, and it contains two types of adsorbents. So we can target from vinyl chloride out to the lighter pHs with one analysis. There's two pairs of adsorbents in there, so we can have a duplicate analysis for every location, or also have confirmatory analysis if anything doesn't look right with our QC checks. Each sampler has a uniform massive adsorbent present, which is verified with an analytical balance, which is important because what we're looking at is relative differences from one location to another. So you want to have everything in control as much as possible with your sampler and the analyses, because what's out of control is the variability in your subsurface. Our sampler is also completely inert. If you notice, there's coloration to the sorbent traps that's inside that vial, because we put the stainless steel meshing frames through the same passivation process that's done for the inside of Suma canisters before we put adsorbent in there. So the sampler is completely inert, which is in accordance with the ASTM requirements. We ship it out with a solid cap on it, which is white there, that's shown on top. When you're ready to install it, you just remove that solid cap, put a sampling cap on there that has a hole through the center covered by screen meshing to allow gases to freely come into the vial, extend that retrieval wire out from it, and lower it down into the hole. Simple process. All right, there's various adsorbents that are used for targeting organic compounds, whether it be in soil gas or air. And you can have carbon molecular sieves, blacks, polymers, and they all differ in their composition, as well as their surface area and their hydrophobic properties, and their ability to absorb and then release compounds. And so it's important to know what compounds you're targeting and to make sure that the appropriate adsorbents are used. This slide here shows some of the different adsorbents that are available. The ones at the top of the table have a low surface area. You can see 5 meters squared per gram, as opposed to the adsorbents at the bottom of the table that are 1,500 meters squared per gram. Those adsorbents at the bottom are much stronger, they're more tenacious. They'll hold on to very volatile compounds, letting get back to the laboratory for analysis. But the adsorbents at the top, they'll allow you to target much heavier compounds and be able to desorb them off again, either by thermal absorption or solvent extraction when back at the laboratory. So it's important to work with your passive vendor to make sure that you're using the appropriate adsorbents to target the compounds that are of concern at your site. To install samplers, it's very straightforward. Using simple hand tools, we recommend using a hammer drill with small diameter drill bits, typically 1.5 inch diameter down to a 1/2 inch diameter, where you're creating holes as shallow as 1 foot down to 3 feet. And it can be used both in grass covered areas as well as through asphalt and concrete. For more detailed procedures, you can go to our website where you see full videos showing the installation procedures. I want to talk a little bit about the design considerations that you should keep in mind when you're developing your soil gas survey, particularly for passive soil gas surveys. We like to have our samplers out in uniform grids. That way you are less likely to have a bias and miscontamination, because contamination is typically not where you're going to expect it to be. There's always surprises out there. And often when there's not enough samples collected, we see hot spots on the edge of grids. So we really try to work with our clients to develop an appropriate grid pattern across the site that'll have good coverage and still stay within the budget. You can also use a more focused sampling pattern if you have just specific areas to investigate, like underground storage tanks, septic fields, known features where you really just want to focus to see if there's been releases there. When we're tracking contamination in groundwater, we put samplers out in transects, and we've tracked groundwater contamination at depths greater than 75 feet. With this approach, we recommend having the samplers in spacing of 25 to 100 foot between samples within the transect. And then transects typically are 100, 200 feet or further apart, depending on how large the plume is, so we can really focus in where the center of the plume, the contamination in the center of the plume. For identifying source areas, we recommend spacing of 15 to 30 foot to identify those source areas and make sure we're not missing contamination. But some sites are obviously too large for that tight of a grid pattern. The budget won't allow it. There we recommend stepping out to a larger grid, 50 foot or even larger. Make sure you still have coverage across the whole area, but then tightening up the grid in those areas of greater concern based on available site information or features that you see out in the field. When sampling for shallow groundwater contamination, you're going to need to use a tighter grid spacing because there's less distance for the gases to diffuse from the groundwater to the near surface. The main path that gases want to follow is vertically, all things being equal, based on gravity and pressure. But gases also will diffuse out diagonally and laterally to a lesser degree. So the less distance you have from the near surface down to the source where the contamination is present, the closer you're going to need to have the grid spacing. And utilities also to keep in mind, they can be to your advantage or work as a disadvantage for your survey. Because if you're looking for contamination, you put your samplers above known utility lines, they'll act as a sink for gases to accumulate in there and migrate along that utility line, and then some of it will be diffusing upward where we'll be picking up with our passive sampler. But if you were to have a utility line going through your site that you didn't know about, you might have a measurement there that's an anomaly and think it's a hotspot when really you're just picking up contamination from a utility line that's transporting it from a remote location, someplace laterally distant. So I mentioned the samplers can be installed in typically holes to a 1 to 3 foot depth. They can be installed in holes that are extended to a greater depth by using direct push. We've advanced holes down to bedrock and we've sleeved down to different depths to isolate where the contaminants are going to be measured. But ideally, you want to minimize the size hole that you've created so that reduces the amount of time required for the gases to reach an equilibrium again with the concentration that's in the surrounding soil pore spaces. As far as an exposure period, when you're sampling, looking for source areas or identifying vapor intrusion, a pathway and risk, 7 days or less is fine. In fact, we've done surveys that only had the samples out for 24 hours. However, when you're tracking groundwater contamination or contamination at greater depth, you want to leave the samplers out longer. And by using a robust sampler that has a large absorptive capacity, you can leave them out for 14 days or longer, even leave them out for a month or longer, which we've done, to make sure that you have the sensitivity and that you're also, while you're might be looking for source areas as one of the objectives, the other objective is to see if contamination is migrating off site. So you still want to be able to meet that objective of picking up contamination in the groundwater. And by leaving a sampler out for 14 plus days, you'll be able to meet both objectives. The actual sampling period is going to be dependent on the site conditions, the soil porosity, how tight the soils are, as well as the soil moisture, which will reduce the diffusion rate of gases, and the compounds of concern, how heavy they are with some molecular weight. These things you want to talk with your vendor and get their experience on how long the sample should be kept out. As Mort said, in soil gas, you can target a broad range of VOCs. We routinely are targeting chlorinated and petroleum hydrocarbons with method A260C. And we're looking also for TPH, looking for the lighter and heavier fraction that might be present out there to discern the age of the contamination and the type of contamination of its petroleum that's present. We also can target 1,4-dioxane, which is an emerging contaminant of concern. We routinely target this. It's in our scope of accreditation, and we have seen it at many sites with chlorinated contamination out there. It's a very water-soluble compound, but it still will show up in the vapor phase, particularly when the 1,4-dioxane is present in soil. Passive approach will let you expand the range of compounds you can target as opposed to active soil gas sampling, because the adsorbents will trap heavier compounds that you're not going to be able to get back out of a suma canister, or is not appropriate for Tedlar bags or glass vials or other sampling methods. So with a passive approach, you can target ACE, naphthalene, fluorine, heavier pHs, but also explosive compounds, pesticides, herbicides are targeted, alcohols and ketones can be targeted, as well as chemical warfare agents, which done on a few unique sites where our sampler have actually identified mustard nerve agent in soil vapor, which the analyses were performed by a government laboratory, and we understand that that was the only times that these compounds have been seen in soil vapor as opposed to air. All right, so passive soil gas samples can be analyzed with a variety of methods using thermal absorption or solvent extraction to introduce the sample into the system. Beacon analyzes all of our passive soil gas samples using thermal absorption to achieve the greatest sensitivity and reproducibility, and uses GCMS instruments to provide the highest quality data. While a passive soil gas survey is used to screen sites, the data can be of excellent quality by using GCMS and including internal standards and surrogates with all the analyses. Because Beacon is DoD ELAP accredited for method A260C, quarterly limit of detection and quantitation demonstrations on each system are performed as our biannual proficiency tests for each compound on our scope of accreditation. So you're receiving data of a very high quality, although it's only screening results. And using gas chromatograph with a mass spectrometer with thermal absorption allows us to have a very low detection limit that can be reported at a high confidence. The demonstrated limit of detection for each compound in our method is 0.005 micrograms or 5 nanograms, with even lower method detection limits. Now, the data reported with a passive soil gas survey is in units of mass of individual compounds that are absorbed throughout the exposure period. Federal and state regulators are not accepting passive soil gas data converted to concentrations, but reporting the data in units of mass still meets the objectives of a passive soil gas survey, which is to collect high-resolution data to effectively screen the site in order to focus where soil and groundwater samples should be collected, to identify whether a vapor intrusion risk might be present, tracking groundwater plumes, and focusing remediation efforts. That is to make sure that you are injecting or extracting in those areas where your efforts will be most effective. The data being reported in concentration is not critical because we know that the soil gas concentration is going to change, but what is important is acquiring data that best reflects the variability in subsurface contamination and meets the objectives of the survey. With a passive soil gas technology, you want to make sure that there's as much uniformity as possible in both the sampler design and the analytical method, so you're able to achieve the goal of producing data that not only identifies hotspots, but also maps the lateral extent of contaminant plumes. All right, so switching gears, I want to go over a case study I finished up my talk with, where a passive soil gas survey was performed to identify hotspots as well as the lateral extent of tetrachloroethene and soil gas beneath a former dry cleaner and adjacent spaces. Beacon supported the environmental consultant with both the soil gas and the indoor air sampling for this project. This property is located in a retail mall in an urban area where a new tenant wanted to take over 2 units that housed a former family-run dry cleaner and a store. The red line shows the location of the former dry cleaner, which it, along with the former retail store, were vacant at the time of the investigation. The first step was taken by the consultant to collect indoor air samples within each of the 2 spaces that are separated by a block wall with ceiling heights about 12 feet. The results found that the indoor air concentration of PCE was 22 micrograms per cubic meter, which was above the acceptable level of 8. A quick screen was then performed by developing temporary vapor ports that were purged with 3 volumes of air and then sampled using colorimetric tubes appropriate to target PCE. Screening results of 1.5 and greater than 10 ppm of PCE indicated further characterization was required to identify the extent of contamination in order to assist with the design of an appropriate remediation approach. The consultant first wanted to sample the indoor air not only in the 2 spaces to be renovated, but also in the other adjoining spaces and hallways. Samples were collected over an 8-hour period in the breathing zone at approximately 1.5 meters above the floor using sorbent tubes and low-flow pumps following method TO17. The results found an exceedance in the former dry cleaner space near where the dry cleaning machine was previously located, as the first round of sampling had also indicated. But all other measurements were below the exceedance level of 8 micrograms per cubic meter. A PSG survey was then developed to assess the extent of contamination in soil gas beneath the former dry cleaner and the adjacent space to be taken over. A high resolution grid with 20 and 15-foot spacing between locations was employed. This slide shows the sampling configuration used at each location, where a 1.25-inch diameter hole was advanced to a 12-inch depth, and then a 1/2-inch diameter hole was extended to a depth of 3 feet. The upper 12 inches of each hole was sleeved with a metal pipe to isolate the depth at which soil gas is sampled. This is important because the more porous subgrade material beneath the concrete slab will act as a preferential pathway for lateral gas diffusion. And we have found that soil gas data better represents contamination in soil and groundwater when you prevent the sampler from sampling soil gas immediately within the subgrade material. So once again, here's a slide showing the PSG survey grid in relation to the indoor air samples. And I should note that it required 4 hours for a 2-person team to install the 38 samplers, and then following a 7-day exposure period, a 2-person team retrieved the samplers and patched the holes over a 2-hour period. Samples were then submitted to Beacon's lab and analyzed following method 8260C. And what we found was the hotspot was where it was expected, but the contamination was extending south in the direction of the expected groundwater flow as well. You'll see the locations north of the former dry cleaner reported lower measurements and non-detects, suggesting that the plume was not extending further beneath this large retail mall, but possibly was extending out beyond the outside wall south of the dry cleaner space. Following collection of the passive soil gas samplers, 3 temporary vapor ports were installed at locations down gradient from the suspected hotspot to additionally measure soil gas concentrations at 12-inch depth. The 3 locations sampled are shown in the red triangle. These samples were collected using sorbent tubes and low-flow pumps, and then were analyzed following method TO17. The results from both the passive and active soil gas samples are shown here in this table, and you will note the strong correlation between both data sets. As an additional exercise, because it was not necessary for the objectives of the survey, but we was interested to see results, Beacon analyzed the correlation between the passive soil gas and the active soil gas results at these 3 locations using a power function to best represent the relationship with the data that has an order of magnitude difference. The power function equation is shown in the graph, as is the correlation coefficient, which you can see was exceptional. The table below provides what the calculated concentration would be at each of these 3 locations by applying the power function equation to the passive measurements. As you can see, the relative percent difference between the measured and calculated concentrations is very good. Next, the power function equation was applied to all passive soil gas results to calculate the soil gas concentration for each location. This approach is what we refer to as the master concentration tie-in, and additional information on this can be found on our website. But these results were then mapped for comparison to the original passive soil gas data and to provide estimations of soil gas concentrations beneath the slab. So what we see here is that the data set provides an example of the spatial variability of soil gas concentrations that are routinely found, which highlights the challenge of collecting a single soil gas and indoor air sample to establish an attenuation factor. Based on the results of the soil gas survey, a subslab depressurization system with a fan was installed as shown here in those areas of highest concentrations as determined by the passive soil gas survey to effectively mitigate the soil gas and resulting indoor air concentrations. After the system operated for a week, indoor air samples were collected following method TO17 and analyzed. Results showed that the concentrations first measured in August had dropped to acceptable levels by October, and that the new tenant was able to start renovations to occupy the 2 units. So in conclusion, spatial variability of subsurface contamination is the norm, and that's what we've seen for over 20 years of doing thousands of soil gas surveys. And high-resolution sampling strategies will significantly increase the probability of not only identifying the presence of contamination, but determining where the center of mass is located, so remediation efforts will be more effective. Passive soil gas methods, which collect time-integrated samples over days or weeks, are less likely to produce false negatives. And the passive soil gas technologies that have a good quality control in both the sampler design and the analytical method will produce data that best reflects subsurface contamination. And a passive soil gas survey can target a broad range of VOCs as well as SVOCs to locate organic contamination and guide your remediation strategy. So with that, I want to thank you again for attending our talk, and I invite you to submit questions through the portal. And Jordan, do we have any questions that were submitted this time?
We have a few. Actually, we can start off with ones for Mark. First question.
Am I unmuted?
Yeah, you are. You are.
Okay, good.
Yeah.
All right, I had several questions here. One asked, have we used this technique to look for 1,4-dioxane? And the answer is we haven't really looked for it. Depending upon your analytical method, when we've used the small glass vials, the 22 ml evacuated bottles, we're looking for, we can see 1,4-dioxane because we're using a straight gas chromatograph. But as you may know, the GCMS, because of its water removing, etc. procedures, is not very good for 1,4-dioxane. So when we're using larger containers, and we've done this, summa canisters typically, we're usually getting a very poor reporting level for 1,4-dioxane, but we could potentially see it.
I can still see it actually here.
Am I still good, Jordan?
Yeah.
Okay.
We're actually going to.
Okay. Okay. Had another question here, radius of influence with a 6-liter canister. Somebody, I think in the Hawaii guidance, someone calculated how far you could see depending upon how much soil gas is going to go into a container. But I did a back of the envelope calculation just now. A 6-liter summa canister, if you had 35% porosity in the sand, gravel underneath a slab, that would represent 0.6 of a cubic foot of sample. So depending upon how thick your sand gravel is underneath a slab, you'd see several square feet. You'd have maybe a 1 or 2 foot radius, but not real big with even a 6-liter summa canister. So a radius of influence, maybe a foot or 2, depending upon the thickness.
And Mort, this is Roger. I ran those numbers. Now I assumed a 20% porosity and then a thickness of fill material on the slab of 15 centimeters, and I come up with about a 25 centimeter radius of influence. Just for comparison, for a 100-liter soil gas sample, say sub-slab, that comes out to about a 100 centimeter radius of influence. And for the first person who can figure out how to get a 100-liter sub-slab soil gas sample, I'll buy them a beer at Duke's in Waikiki.
Does that include airfare?
If you pay for the yeah, exactly.
I will send a rowboat.
Sounds good. Okay, had another question. Does a large number of points increase the risk of vapor intrusion? I think what they meant by that is, do you have a risk of failing? You're not going to actually cause vapor intrusion, assuming you don't have a leaky point. And again, depending upon what you're using, I haven't had trouble with the vapor pins leaking. But I think what they were really asking is, does a large number of sample points increase your risk of exceeding your soil gas screening level? And the answer is yes, it does, because it's a whole lot easier to pass vapor intrusion screening levels if you never really find the problem. But unfortunately, you do want to see the problem. I should mention to that end, I submitted comments to the EPA guidance where I suggested that instead of using an attenuation factor of 0.1, you should be able to use something much more plausible like 0.01 or 0.001 if you collect 8 or more samples or something along that line. But yeah, you're more likely to find a problem, and that's good. I should mention, by the way, that most of the time when we do these screening things, it's not the exception, it's the rule that we find the real problem is not where people thought it was. So yeah, that will happen if you collect a lot of samples. There was another question on how long you can leave. I think it was the same questioner. How long can you leave the vapor pin in place? 4 or 5 years, whatever. I've left them in place typically for no more than a year because I'm doing that for vapor intrusion sampling. We usually need to sample 4 quarters. So we'll go back 4 times and then pull it and remove it. The brass vapor pins, I usually use brass if I'm doing one-time sampling, stainless if I'm doing, if I'm leaving it in place. Just of course, it's more corrosion resistant. But if I'm only doing a one-time event, of course, then we pull it out at the end. And I forgot to mention earlier on, but the vapor pin is reusable. You strip off the silicone sleeve, decontaminate it, and use it again. And I've used mine on average 7 or 8 times each. So the second time, they're virtually free. But I've left them in as long as a year. And someone asked this, I've left a few of them in place for several years. They asked, does the silicone sleeve wear out? Not that I know of, not in the samples I've seen. If you had a very high level VOC, hydrocarbons or something, maybe it might react, but they'd be very simple to pull out and replace and hammer back in, I suppose, if you had to, but I have not seen that. Finally, there was a question on cost of study we did of the 144 plus points. The simpler thing, probably depending upon your rates, your billing rates, etc. We had the hour cost was 2 guys, 40 hours, 80 people hours, a hammer drill and a PID or a multimeter, and the vapor pins themselves. Of course, vapor pins for me are cheap, but what you would pay for a vapor pin, we have the contractor kits that include the installation tool, etc. You only really you don't need all those things for 10 times. But the contractor kit has 10 vapor pins and those accessories, and then stainless it's 850, brass is 750. Individual pins, if you want more, are $50 for stainless, $40 for brass. And again, they're reusable. So the first time out, it'll cost you a little more than stainless steel set in cement. But by the second time, at least you've broken even, and the third time they're virtually free. If you're interested in vapor pin, looking at them more and getting prices, they also have accessories, filters, etc. If you feel the need that attach to the underside of them, you can go to www.vaporpin.coxcolvin.com. So, and there was one other question about the radar plus. It is not published. I gave a presentation. I gave a webinar for MSECA, MSECA. I've given a couple of other presentations, and I'd be happy to send you a white paper. I'm planning on publishing it later this year. But if you contact me, if you email me through coxcolvin.com, and my name is Mort Schmidt, MORT_SCHMIDT at coxcolvin, one word, COXCOLVIN.com. I'll be happy to send you an article that describes that radar plot stuff. So, thank you very much.
Yeah, thank you, Mort. And I'm going to turn things over to Harry now so he can go through some questions that he has. And yep.
Okay, thanks, Jordan. Yeah, there was a question on the range of being able to pick up contamination at what depths we can see contamination. That's going to be all dependent on the soil conditions and the compounds we're targeting. From experience, we've seen contamination in depths greater than 75 feet. Obviously, that's in soils that have a larger porosity, allow the gases to diffuse to those great distances. But we've had excellent correlation with follow-on wells that were installed by tracking a plume in the southwest United States, where we first set up transects to determine the extent of the plume, and then we came back with a line of samplers parallel to the groundwater flow to really zero in on the length of the plume. And it's going to also be dependent on the type of compounds that are being targeted. The chlorinated compounds, they will attenuate much less likely than the petroleums, and so they were recalcitrant, and they will make it all the way up to the surface, where the petroleum hydrocarbons, particularly BTEX, will attenuate when it gets into oxygen-rich environments. So there we tend to look for the aliphatic hydrocarbons and look at TPH more so than the aromatics. We're looking for petroleum contamination. But even still, with petroleums, we've seen contamination at considerable depths. Ideally, when looking at contamination down at 20-foot, we consider that not to be a challenge, unless it's very tight clays. But for sites that have greater depths to contamination, we can also set up pilot studies first to make sure that it works before we go ahead and install the samplers. We had another question about, can you have too many compounds being present? Does that cause a problem for the sampler? Well, the adsorbents that we use have a wide range of affinity for compounds, from very light vinyl chloride out to PAHs. And we've done surveys where we've seen well over 80 compounds present on the sampler from what's in our calibration, as well as what we have looked for as ticks, tentatively identified compounds, and at very large masses also. So we have seen our adsorbent samplers be able to adsorb a broad range of compounds, seeing PAHs at the same time vinyl chloride and other light compounds are showing up. Another question is on the effects of rain and moisture. Rain obviously can cause the pore spaces in the soil to be filled up, and the gases will not be able to diffuse through those pore spaces while they are saturated. However, you put the samplers out, you say they're in dry or just typical conditions, and then you have a rain event and the soil pore spaces fill up with water. Gases will not be moving then, but as the water subsides after the rain event ends, gases will then start moving again. And because we're using hydrophobic adsorbents, they will continue to absorb compounds even if they become wet. It's not necessary to have a membrane or plastic around them to protect them. We had some questions about reporting the data as a concentration, as we did with the mass deconcentration tie-in. That is a exercise that we can provide on a site-specific basis, where we have the measurements by passive soil gas as well as active soil gas, establish that correlation for the site, and then apply it to all the sample locations to derive what the concentrations were at each of the locations. That is data that can give you guidance still on the concentration. It's not concentration that's going to be accepted at this point by regulators as a definitive concentration. But keep in mind, the purpose of the passive survey is to screen the site, to determine where you have contamination, whether it be in soil, groundwater, or even soil gas. If a risk assessment concern from vapor intrusion is the objective of the survey, that is the follow-on investigation to be required to determine what is the concentration that's present there, and to sample at different periods to see what is the average and high concentrations that might be present. So it's a separate objective. But by reporting the data in units of mass, as a passive soil gas survey does, still meets the objectives of determining where you have contamination in both soil and groundwater and where you want to focus your remediation. And there's a lot more information on our website. I know we're past the hour, as well as case studies. And you can contact me. You've seen my information there, or call us directly at our office at 800-878-5510. And we'll be glad to evaluate your applications and share more about how passive soil gas technology is used to overcome the challenges from spatial variability in subsurface.
Okay, thanks, Harry.
Hey, Harry, this is Roger. I have one more question for you. Let's say I want to determine the mean concentration of a VOC within the middle 1/3 of a building slab. Can you install multiple passive samplers and then combine them in the analysis, so I just get one analysis and just one number? I'm not really interested in the variability. I just want the mean.
We can. So
also,
yeah, what you refer to is you have a decision unit there in your building, and you want to determine what the mean is for that. What we would do is we would have a sampler at each of the location, and then when we get it back to the laboratory, we can set it up in our system to desorb each one of those traps onto a focusing trap, and then analyze that focusing trap to give you the measurement from all locations with one analysis. So that can be done.
So that would allow me to put in a lot more passive samplers within my decision unit area to get better data quality.
That's right. And so you get more data density while still keeping your analytical costs down, because it wouldn't require as many analyses.
Okay, great.